If your boiler's fire rate at startup is 30% and it's 30 seconds before the modulation kicks in, which would be, again, low and conservative, on a 2 million BTU boiler, that's 5,000 BTUs. Where is that energy going? It's going into the water. You're putting 5,000 BTUs in the water. How much water does that boiler see if there's no volume in it to begin with in 30 seconds? With a 10 GPM, it will see how many gallons? 5. Right, think about that. So you're telling me 10 gallons per minute, it would only see 5 gallons of water, and I'm putting 5,000 BTUs in 5 gallons of water? What's my temperature rise going to be in 30 seconds? Would you believe 120 degrees? If your flow rate was 20 GPM, how many gallons of water would it see in 30 seconds? It would see 10 gallons. And you're putting 5,000 BTUs in 10 gallons of water because there's no volume of water to speak of in these little water tube boilers. There's very little water in them. Now you're over 60 degree rise. So that based on your controls, what would your manual high limit temperature do? It would kick out. At 10 GPM, for example, and your return water is 164, you see what happens? I'm at 284. So you are praying that it does kick out on my manual high limit, and that's what happens at startup. This is an age-old problem with people not understanding there's a minimum flow rate through a boiler to get it started. Boilers don't start modulated. They start at some other reduced fire rate to get it up and running, and people don't worry about it because it only lasts 30 seconds. Well, it can be an issue, as you can see. Repeating my numbers again, my 5 gallons of water, you see my temperature is 284, and you see I got an issue. So the answer was 284, 30 seconds was an issue, so I challenge you. If you will tell me, any boiler on the face of the earth, how you started up, what is the fire rate of your boiler at startup? I'm not talking about how far it modulates down. That's not the answer here. I've got to ask you, at what rate does it fire at startup? Number one question. Second question, how long? Does it take it 30 seconds, 40 seconds, 60 seconds? Now I've got BTUs. The next question is it having a volume in the system? To be safe, I think we better flow it at a rate enough to make sure we don't hit manual high limit. So if you give me those two numbers, the fire rate of the boiler startup and how many seconds, I'll tell you what your minimum flow rate is on your boiler, any brand of boiler you want to call and ask us on. It's that simple. Trying to keep you out of trouble. This is a major issue that people have really not picked up on. So boiler cycle time. We talked about cycle time and startup. It's two different issues really that tie together. You got to get the idea of the fire rate at startup, that minimum flow. Now I'm over the short cycle of my boiler. So let's look at, we are modulating the boiler down or whatever the minimum fire rate may be. What are your goals with a boiler to get long life out of it? You want your boilers to run for a minimum of 5 minutes. You go through this whole cycle, get them heated up. You want to run a minimum of 5 minutes. And in theory, if you ran 5 minutes, you'd be off 5 minutes, you'd have a 10-minute cycle time total, which would be kind of the minimum we like to see between on and off. So what controls your boiler cycle time? What controls the on-off numbers? It's very simple, really. It's the volume of water in your system that the boiler can see. The boiler has to be able to see those gallons of water, and the delta T between on and off. That's why I showed you a slide earlier about cutting off at what was at 186 and cutting on another boiler at 174. I was using a 12 degree. I think 12 degree delta T is a good number to play with here between on and off. Now remember, once the boiler's load and the boiler output match, we can hold very tight. We won't be 12 degrees. We'd be very tight. We're talking about on and off. We're talking about when do we turn this thing on, when do we turn it off, what is that delta T the boiler's got to play with, okay? So let's take a quick look and see where we are. So basically, if we kind of hold that delta T, here's a set of numbers and there's a rule of thumb that I kind of came up with using 12 degrees that I think you should keep in mind. Here's your calculation, so keep it simple. Every 100 gallons of water in your boiler and in or your system total that the boiler can see can hold 10,000 BTUs at a 12 degree delta T. In other words, you got your boiler at 186, you cut it off. The boiler stayed off until the temperature dropped to 174, and you brought it back on. Repeat that. Your set point was 180, but the boiler goes off at 186, and at 174 it comes back on. That's a 12 degree delta T between on and off of your boilers. you can take that 12-degree delta T, and for every 100 gallons of water in your system, you can store 10,000 BTUs. Now you begin to see how these buffer tanks need to be calculated and how we're beginning to take a look to stop short cycle. And this is very simple. That's why I like the 12 degrees. It's an easy rule of thumb to hang on to, and it's a good practical number between on and off. I'm not talking about operating temperatures. I'm talking about between cutting on and off of your boilers. So I take that concept a step further. Here's a little situation where I've got a 1,000,000 BTU boiler, and that's going to be my minimum fire rate. It's 1,000,000 BTUs. It's a big boiler. Turn down is only to 1,000,000, so turn is not real good, but it's 1,000,000 BTUs. It'll be my minimum modulated fire rate. Could be 100,000. Whatever number you got is a minimum fire rate. I'm going to use 12 degrees here. I'm going to use a 12-degree delta T. And if you walk through the numbers, my 5-minute runtime, minimum fire rate of 1,000,000 BTUs for 5 minutes is 83,000 BTUs. If my turn down was 100,000 BTUs, I would only have 8,300 BTUs to get a 5-minute runtime. In other words, I want to make sure between on and off, between 12-degree delta T, I can put 83,000 BTUs into my system to make sure it runs a minimum of 5 minutes. And that's going to take, if I use 12-degree delta T and 10,000 BTUs per 100 gallons, it's going to take 833 gallons of water in my system to make sure that a 1,000,000 BTU fire rate runs a minimum of 5 minutes. Now, that would be a big system, I agree, but all you got to do now is calculate the volume of water and everything, make sure you've got 833 gallons. I'm just trying to walk you through an example. So here's the actual formulas for runtime. Now, I'm not taking advantage of what I just said in the load. I'm just assuming there is no load. Because I like to calculate these things as if there is no load. Your runtime is there, your off time is there, you got your BTUs, and you show your pipe sizes to come up with gallons per foot to estimate the gallons of water in your system. Well, again, we recommend 5-minute minimum runtime. We're going to assume it'll be all 5, so we got a 10-minute combination here that's kind of the minimum we'd recommend. You can make yours anything you want. We're just giving you something that's practical that most people will support. So by putting all this together, you might need a buffer tank when you do these calculations to get this extra gallons. Again, if it's a water tube boiler, you probably will need that buffer tank because there's very little water in the boilers to begin with. If you have a fire tube boiler, it has a lot more water, but we still need to do the calculations. We've got to sit down and calculate it and make sure. And again, that delta T and the volume is the key. What delta T you're going to set your boilers on to cut on and off. On, off, delta T. That's the key to how many BTUs you can store to handle a short cycle. The higher the delta T and or the higher the volume of gallons of water, the longer runtime I can get, the more I can kill the cycling issue.